What's up, everybody? Mr. Cozad back again for part 2 of the 7.5 lesson series. Part 1 last time was about just simply the properties of logs. Part 2, we're going to take those properties and apply them in the context of solving some more interesting log equations. 7.4, we already learned how to solve log equations, but 7.5, we take things up a notch and solve, like I said, more interesting log equations. So there's basically two types of logs. And before I get into it, if you haven't watched part 1 yet, you definitely need to go back and do that. So stop this and find 7.5 part 1, properties of logarithms. That's going to be a good place to start, and then come back and pick this one up. Okay, so at any rate, like I said, there's two different types of problems that you're going to encounter when you're solving logs. Is you can have logs on both sides of the equal sign. Okay, so here the first thing that you obviously want to look for is the base the same on all of these. Okay, so I see base 4, base 4, base 4. So that's obviously passes the first test that we can do some work here with this. So then what we've already learned in 7.5 is when you have two logs that are separated by an addition sign, we can combine those two logs using the product property. Okay, so we can rewrite that as one log base 4 of x plus 3 times x minus 3. Those are ugly 3s. Let me clean that up for you. So log of base 4 of x plus 3 times x minus 3. And then let's leave the right-hand side alone. Log base 4 of 3 minus 4x. So if we clean up the left-hand side a little bit and actually do that multiplication, okay, x plus 3 and x minus 3 are conjugates, so foiling that out, it's actually pretty easy. We get x squared minus 9 equals log base 4 of 3 minus 4x. So now what we've done is we've taken a 7.5 problem and we've turned it into a 7.4 problem where we just solve basic log equations. So here, because I have log base 4 on both sides, okay, I can set the inside part of the log, x squared minus 9, equal to 3 minus 4x. So we have a quadratic that will group everything on one side. So we get x squared, that's actually plus 4x minus 12 equals 0. So we have a trinomial here that should be pretty easy for you to factor. You're looking for two numbers that multiply to give you negative 12 and add up to give you positive 4. So I get x plus 6 times x minus 2 equals 0. And then we set each of those factors equal to 0, and we get x equals negative 6, and we get x equals 2 as my solutions. Now, since you, in the original problem, since you had some multiple x's here in your original equation, we need to plug both of these x values back in to see if they both work. And remember, when we check our answers, after we want to be careful about x values that we plug in where we're asked to find the log of a negative number. We get an error when we have to take the log of a negative number. So that's specifically what we're looking for. So I'm going to make myself a note over here where I'm checking my work. Okay, so the first one I'm going to check is x equals negative 6. So I go back up to the original and I'm going to plug that in. And the first log I see is log base 4 of negative 6 plus 3, which would be log base 4 of negative 3. So, are you ever allowed to take the log of negative 3? The answer is no. So when I use negative 6 as a possible x, I would be required to do something that is illegal. We cannot do that. So we're going to reject x equals negative 6 as a solution. Again, I'm rejecting that because when I plug it back in for x, I'm required to take the log of a negative number, and we cannot do that. So now let's check the next log. So we get log base 4. I'm going to use x equals 2 this time. I get log base 4 of 5 plus log base 4 of negative 1. And there you go. You have to take, when you use x equals 2, you'd have to take the log of a negative value again, which is no. We cannot do that. So we actually reject x equals x equals 2 as well. Since we rejected both of our solutions, we would say that this problem has no real solution. No real solution. Okay? That will not always be the case, but obviously you just see here that it is possible sometimes for every solution that you get using perfectly valid mathematics, when you plug it back in, gives you an error based on the function that you're dealing with. Okay? So let's look at the second type of more interesting log equations. This is a type of log equation where you have logs on one side and one side only. Okay? So the way we would approach this is very, very similar to what we did in the last example. We're going to take the two logs on the left-hand side and we're going to combine them into one. Now, since those logs share the same base and they're separated by a subtraction sign, we're going to apply the quotient property where we take 12x and divide it by x minus 1. I have an extra parenthesis in there. I'll get rid of that. And that still equals 2. Okay, so again, what we did is we used some 7.5 to condense these two logs into one. And now once you get it like this is a 7.4 question. You've already practiced solving these. Okay, but the biggest mistake that people are going to make on this problem is they're going to just say, oh, 12x over x minus 1 equals 2. Well, you can't do that because there isn't a log on the right-hand side of that equal sign, so there's no logs to cancel. So what you have to do is you have to rewrite this as an exponential and then solve. So we rewrite it as 5 to the second power equals 12x over x minus 1. Again, you cannot just cancel logs here because you don't have a log on both sides, so you have to rewrite it as exponential. So if we do a little bit of algebra, everybody knows 5 squared is 25. And then I can multiply both sides by x minus 1. That slides x minus 1 out from that denominator and equals 12x. So if we distribute the 25, we get 25x minus 25. I absolutely love this color, by the way. This is my absolute favorite color to do math in. Magenta, pink, not really sure, purple. I like it. That's the color it is. I like it. Alright, I'm getting distracted, so let's keep going. So subtract 12x on both sides, so you get 13x, and then add 25 to the other side, you get 25. Last but not least, divide both sides by 13, and you get x equals 25 over 13. X equals 25 over 13. Now what we want to do, obviously, is we want to plug that back in and check it. Okay, so if we check our work, okay, you actually can check this one mentally pretty well. If we take 25/13, which is positive, and we multiply it by 12, that will stay positive. Okay, because a positive number times a positive number is always positive, so I don't have any problems there. And then when I plug 25/13 in for the second x, I subtract 1. Well, since 25/13 is greater than 1, if you take 1 away, that stays positive, so it actually works. So our solution here is x equals 25/13. So it's only 2 questions, but if you can do those 2 questions, you can do any log equation that we give you. Remember your 2 scenarios. If you have logs on both sides of the equal sign, multiple logs on both sides of the equal sign, get it to be 1 log equals 1 log. So use some of those properties to condense those logs into 1 log equals 1 log, and then you can cancel out the logs and go from there. Or if you have a type 2 equation, you want to get 1 log equals a number and then rewrite it as an exponential and solve for x that way. I hope this was helpful. That's everything you need to know for 7.5, and you are ready for everything you're going to see in your homework and on the next quiz. All right, guys, I'll talk to you later. Bye.